Okay. So we were on indicators. I'll just put this thing up. Yeah. So we were on indicators. So we cannot taste every object and find its nature, right? We should not and cannot taste soaps. We cannot taste highly concentrated acids like hydrochloric acid, right? So, the property of acids is like acids or bases. Both are very harmful. You should not touch them or you should not play with them. Okay. If you try playing with hydrochloric acid, there is a type of example that if you put hydrochloric acid from above your hand, it will come from below your hand, making a hole into your hand. It's that harmful. Okay. So, but how we'll understand whether a substance is a base or acid? By using indicators. An indicator is a substance that can determine if the other substance is acidic or basic in nature. The indicators indicate the presence of an acid or a base in a substance by changing their color. Okay. Yeah. Coming to the next. Examples of indicator. Now there are 4 types of indicator. Those are litmus, turmeric, China rose and phenolphthalein indicator. Now first of all, litmus, turmeric and China rose, these 3 are natural indicators. They are found in nature. Okay, litmus is found in lichens, a type of plant, lichens. Okay, while phenolphthalein, it is chemically obtained. Now coming to litmus. Litmus is a natural indicator. It is extracted from lichens. It has a purple color in distilled water. Distilled water means neither acidic, neither basic. It is purely neutral. In that neutral substance, it has purple color. When added to acidic solution, it turns red in color. What turns red in color? Litmus paper turns red in color, and when added to basic solution, it turns blue in color. Generally, red and blue litmus papers are available. Now, this is the change or effect on the red litmus paper and blue litmus paper. Tap water. Okay, tap water is neutral, right? So, red litmus paper or blue litmus paper, both would have no change in them. Sorry. Okay, so detergent solution. Detergent, just now we discussed detergent, soap, any kind of soap is basic in nature. So, the effect on red litmus paper, red changes to blue. Now, how we'll remember this? Remember, acid to be, from our childhood we have heard, right? Yeah. So, from our childhood we have been hearing that acids are very harmful. So, remember acid color to be red and base color to be blue. So, whenever I test it with the base, the red color becomes blue. And whenever I test the litmus with an acid, the blue color becomes red. Okay, acid should have red color and base should have blue color. Okay, the litmus paper color changes, not the solution color. Okay, aerated drinks, the changes to red means aerated drinks are acidic in nature, aerated drinks. Okay, soap solution, again, it changes to blue because it is basic in nature. Shampoo changes to red. Shampoo, it is acidic in nature, hence it changes to red in color. Common salt, it is neutral and hence no change. Sugar solution is also neutral, hence no change. Vinegar, it contains which acid just now we learned? Yes, tell me. Acetic acid. Okay, vinegar contains acetic acid, which is, hence it changes blue solution to red, blue litmus solution to red. Okay, now the baking soda solution, we'll just learn that baking soda is a base or an acid. Tell me. Base.
Acid. Base.
Base. Okay, very good. It is a base. So it changes red litmus paper to blue. Milk of magnesia is again a base and it changes red litmus paper to blue. Washing soda, again it will wash things. So it changes red to blue. Again, lime water, we learned it contains calcium hydroxide. Hence, it is also basic in nature. Okay, now coming to turmeric indicator. Turmeric indicator, it is always available at your home. You can do many experiments with it. To use turmeric as an indicator, it is generally mixed with water to form a paste, which is then put on blotting paper. Blotting paper, any kind of paper. Usually it is soft and particle type paper, blotting paper. Okay, which absorbs the particles and dried to form thin strips of turmeric paper. The turmeric paper is then put into the solution in order to determine their acidity or basicity or basic or acid nature. Now coming to the change of turmeric solution. Okay, in lemon juice, there is no change. Means what? The lemon juice is acidic. In turmeric solution, you should remember, turmeric solution has no change in color in acids or neutral. But when it comes to base, if you put turmeric in soap, it will change to red in color. Okay. Now, orange juice is again acidic, no change. Vinegar, acetic acid, no change. Milk of magnesia, magnesium hydroxide, basic in nature. Hence, there is a change to red in color, from yellow color to red in color. Baking soda, yellow color to red in color. Base, right? Lime water, again red, from yellow in color to red in color. Sugar and common salt, they both are neutral, so no change. Next, coming to China rose. China rose petals are kept in warm water and a colored solution is obtained. Okay, China rose petals are kept in warm water and a colored solution is obtained. This colored solution is used as an indicator to identify the acid or basic nature of the substances. So shampoo, when the shampoo is mixed, the initial color of the China rose is milky. But when shampoo is mixed with it, the final color becomes green. While coming to lemon juice, the lemon juice is dirty white. Okay, it's neither completely white, it's neither completely transparent like water. It is dirty white, means brownish white. Okay, but when we mix the China rose solution in it, it becomes magenta, kind of pink color. Okay, or magenta, anything you can pronounce it. Okay, now soda water. Soda water is colorless in itself, but if I mix China rose in it, it becomes green in color. Similarly, sodium hydrogen carbonate or sodium carbonate. Again, these all are bases, so it will become green in color from colorless. Vinegar is also an acid. Vinegar is acid, so it will become magenta or magenta color. Okay, sugar solution is neither acidic nor basic. Common salt solution is also neutral. Hence, no change. So therefore, here you can see the test tubes, acid, magenta color, indicator is itself light pink color, and base is green in color. In bases, it gives green in color. You should just be able to identify whether a given substance is basic or acidic. Okay, now coming to phenolphthalein indicator. Okay, phenolphthalein is a synthetic indicator. Synthetic means what? It is made in scientific laboratories. Okay, it is a synthetic indicator which is colorless in acidic, but it turns pink to red in basic solutions. Okay, now coming to neutralization reaction. When an acidic solution is mixed with a basic solution, both the effects or both the solutions neutralize or cool down each other by neutralizing the effect of each other. The reaction between an acid and a base is known as neutralization reaction. The products formed are salt and water with the evolution of heat. Evolution, releasing of heat. Formation of salt, here you can see acid plus base gives H2O, that is water plus salt. Here you can see there is a chemical equation here for HCl, that is hydrochloric acid. I'll just write down the names. That is HCl, which is hydrochloric acid, and NaOH. NaOH is okay, NaOH is sodium hydroxide. Sodium hydroxide. So these are the very, very common acids and bases. You will become familiar with them as you grow up or as you learn more about chemistry. Okay, now coming to this is water, and this is known as common salt. Okay, this is known as common salt, which is neutral.
Sodium chloride.
Yeah, sorry.
Sodium chloride.
Yeah, very good. Its chemical name is sodium chloride, or commonly called common salt. Okay, sodium chloride. Yeah. And H2O, as we know, it is water. Now, coming to the next thing. Okay, I'll just erase this. Yeah. Okay. Now, neutralization in everyday life. What are the uses of neutralization? Why are we learning it? First is during indigestion or ingestion, when we take in food. Taking milk of magnesia that we learned just now, which is the base, gives us relief as it neutralizes the effect of excess acidity or acid produced inside the stomach. Okay, so inside our stomach, HCl is produced, which provides or which burns the layer of stomach if we don't eat anything. Hence, we have to take our food on time, or there will be acidity, for which we have to take a base, that is milk of magnesia. Now, second is ants bite. The effect of ant sting, which is caused by formic acid, can be neutralized by rubbing moist baking soda. Now, whenever ant bites someone, okay, you should quickly go and rub moist baking soda, means dissolved in water. Not that much, paste kind of thing, baking soda, we should go and apply. Why? Because formic acid is an acid, and the base present in baking soda will neutralize that acid's treatment or the acid's effect, and hence the skin will not feel any pain there. Soil treatment. Plants do not grow well when the soil is either too acidic or either too basic. When the soil is too acidic, it is treated with bases like quicklime, calcium oxide. You should 100% should remember these names, because these will come surely in your MCQs in the form of what should the soil is too acidic. It should be treated with what? Firstly, quicklime. Quicklime means not that lemon juice. It is the calcium oxide, CaO. Formula, let it be. Just learn the name. That is quicklime means calcium oxide. Or slaked lime. Slaked lime means dissolved in water. That is calcium hydroxide. Dissolved in water, calcium hydroxide. If the soil is basic, organic matter is to be added in it. Why organic matter? Because it releases acids, which neutralizes this basic salt or the basic nature of the soil. Now, fourth point is factory waste. The wastes of many factories contains acids, right? If they are allowed to flow in the water bodies, the acids will kill the fish and other organisms. The factory wastes are therefore neutralized by adding basic substances into the waste areas, waste disposal areas. Okay, so here we complete our chapter, acids, bases, and salts as well.